Hello, and welcome to our lesson today. Today we will learn how to calculate the average rate of change of a function in order to interpret how a function changes over a specified interval. So we've got lots of new vocabulary here, but we're going to learn it. Okay, so first we're going to do a quick refresh. How do we find the slope of a line between 2 points? Okay, so remember, it's change in y divided by change in x. So my two y values are 4 and negative 2. So I have 4 minus negative 2 over negative 2 minus 10. Remember that when we're doing this, we need to make sure that this is our first spot, this is our second, this is our first, this is our second. We need to make sure we keep them together. 4 minus negative 2, that turns into plus. That becomes a 6 over negative 2 minus 10 is negative 12. 6 over negative 12 gives me negative 1/2. And then let's try it with these other points. Again, change in y over change in x. My two y points are negative 2 and 4. So I have negative 2 minus 4 over negative 3 minus 6. That gives me negative 6 over negative 9. Negative divided by negative is a positive. So 6 over 9 becomes 2/3 when we reduce it. Okay, so that's just a quick refresher because you need to be able to find the slope in order to find average rate of change. So let's look at this part. When does it decrease the fastest? So the table shows the temperature T in Tucson, Arizona, T hours after midnight. I don't like the fact they use upper and lowercase t, but it is what it is. When does the temperature decrease fastest? Between midnight and 3 a.m. or between 3 a.m. and 4 a.m.? So in order to check this, we're going to have to actually find our rate of change for each of these. So here I have midnight. Here's 3 a.m. and 4 a.m. So midnight to 3 a.m., my change in y, my output, which is down here, I dropped from 85 to 76. So that is a change of negative 9. And my hours increased by 3. So for between midnight and 3 a.m., my rate of change is negative 3. Between 3 and 4, I dropped 6 degrees over 1 hour, which is a rate of negative 6. So I can tell that I changed faster between 3 and 4 a.m. Whereas between midnight and 3 a.m. is only dropping 3 degrees an hour. Between 3 a.m. and 4 a.m. is dropping 6 degrees per hour. So let's look at this average rate of change. So one thing to keep in mind is that when we talk about rate of change, we are talking about the slope between 2 points. So average rate of change, we look at this function, I can tell that if I checked the slope between 1 and 0, or let's say even, I can't even find that. That's a 1, no, that's a 5, sorry. Between 5 and 1, it would be different than if I checked the slope between 10 and 15, or between 5 and 10. My line is not always changing at the same rate. Here I've got a slope like that. Here I've got a lower slope. Here it's even less. So it matters where we check what our rate of change is going to be. So we talk about this, we talk about intervals. So in mathematics, an interval is a set of real numbers lying between two other numbers. They're called the extremities of the interval. For example, the set of numbers x satisfying 0 is less than or equal to x, which is less than or equal to 1, is an interval, which contains 0, 1, and all the numbers in between, 0.1, 0.11, 0.111, all those numbers in between. It is an infinite set between 0 and 1. When I talk about intervals on functions, our interval is always our x values. So it is always sort of a vertical slice. So I want the interval between 1 and 3, which is right here. So I'm looking at this portion of my graph only. I'm looking for the interval between 1 and 3. So I know my change in x is going to be 1 minus 3. My change in y is going to be, let's see, this looks like it's about at like 8. This one looks like it's about at 27. So 8 minus 27 gives me negative 19 over negative 2. Negative divided by negative is a positive. So that gives me a rate of change of 9.5. But that is only my rate of change over that specific interval. If I look at a different interval, it's going to be different. If I looked at the interval between 3 and 4, it looks like it gets less steep. It's going to be not quite as much of a rate of change. Okay, so when we talk about the interval, again, we are talking about a set of x values. Because remember, our functions, the x values are unique. Our outputs are not. Okay, so let's look at practice. Here, I can see that this function, it is a function because it has there's no place where they have the same x values. It is increasing up through here. Then it stays the same. It is a constant value. And then it starts decreasing, but it's not at a constant rate of change. Here I have a constant rate between negative 10 and negative 2. I have a constant rate between negative 2 and 5. And then we have a variable rate here. But I can tell over the interval negative 10 to so over the interval negative 10 to negative 2, my function is increasing at a rate of, let's see, this is, now let's say about 4.5. Up here it is at about a 2. So it is, sorry, negative 4.5. So it's increasing by 6.5 over, so I've got rate of change of 6.5 over 8, which I could do the math and figure out exactly what it is. It's going to be a little more than 2/3, or a little more than 3/4. At this point between negative 2 and 5, it has a rate of change of 0. I can tell it's 0 because it is a flat line, horizontal line. And then, after 5, it's going down. But it is a curved line. So again, so from 5 to 10, it is decreasing. So we can look at these intervals and give information about it. So now let's look at how we compare functions that are represented by these tables. So which of these functions has a greater rate of change over the interval negative 2 to 2? So that's the only interval we're looking at. So I'm looking at from here to here on this one, and from here to here on this one. So I should have done that a different color, sorry. Let's do that one in blue. So for function 1, my y's go from 10 to negative 6. So I have 10 minus negative 6 over negative 2 minus 2. Negative 2 minus 2. So 10 minus negative 6 turns into plus. So that becomes 16 over negative 4. Which is 16 divided by negative 4 is simply negative 4 is my rate of change there. For function 2, my y goes from 1 to 16. So I have 1 minus 16 over negative 2 minus 2. So that gives me negative 15 over negative 4, which gives me a positive value of 3.75. Okay? So I can tell that this one, that function 1 has a greater rate of change. So when we compare rate of change, we are looking for the absolute value. It is decreasing, but it's decreasing much fast. It is decreasing faster than function 2. Okay, So go ahead and complete your work and see me in class if you have any questions.